हेलो हाय हाउ आर यू ऑल कैसे हो सब लोग वेलकम टू दिस वीडियो। इस वीडियो में आज से हम लोग आईएसआई के लिए प्रिपरेशन करना शुरू करने वाले हैं। तो पहले हम नंबर थ्योरी से शुरू कर रहे हैं, एक एक करके हम सारे टॉपिक्स कवर करेंगे हफ्ते में 2 दिन। एंड स्टे ट्यून्ड। ओके, और क्या ही बोल, मतलब शुरू करते हैं। सो आई होप आप सब आईएसआई के लिए प्रिपेयर कर रहे हो। अभी कितने महीने बचे हैं वो कैलकुलेट कर लो। अगले साल मई में शुरू होगा, है ना, मई में एग्जाम होंगे। सो थिंक अबाउट इट, कितने महीने बचे हैं, कैसे प्रिपेयर करना है, सारे टॉपिक्स क्या क्या हैं, सिलेबस एक बार देख लो, एवरीथिंग। ऑलराइट। तो यहाँ पे हम कुछ कुछ सवाल हर वीडियो पे एक एक कदम आगे बढ़ेंगे। राइट। तो इस वीडियो में देखते हैं हम क्या करने वाले हैं। नंबर थ्री में ये सारे टॉपिक्स में कवर करके कुछ कुछ क्वेश्चंस लाया हूँ और ये हम मिलके सॉल्व कर लेते हैं। ऑलराइट। तो चलो स्क्रॉल करते हैं। दिस इज द फर्स्ट क्वेश्चन। विच ऑफ द फॉलोइंग इज ए डिवाइजर ऑफ दिस? The options are this, and of course I hope आप लोग को पता है what is the new pattern, है ना। सिंगल करेक्ट के साथ साथ there are multi correct questions as well। तो उस हिसाब से आपको आंसर करना है एंड इट इज पार्ट ऑफ द न्यू पैटर्न। सो यहाँ पे आपको देख लेना है क्या क्या होने वाला है। सो आई थिंक पॉज करके वेट कर सकते हो। आई थिंक इफ यू गेस्ड इट और डिड वॉट एवर, ए एंड बी आर द करेक्ट आंसर। ओके, 39 डेफिनेटली डिवाइड्स दिस। तो इसको हम दो तरीके से सॉल्व कर सकते हैं। व्हाट आर द दो तरीके? वन इज mod लेके देखना। सो फर्स्ट यू टेक mod 3, what is happening? So 7 mod 3 is 1, 13 mod 3 is also 1, 19 mod 3 is also 1. So if you add all these things, this will be congruent to 3 mod 3, which is 0, which is congruent to 0 mod 3, right? So 3 definitely divides this thing. And what about 13? So mod 13 भी ले लेते हैं, right? So if you take mod 13, देखो, what is 7 mod 13? Well, this is the middle one is 0. This is 6 power 39. And this is, if you see carefully, this is minus 6 power 39. तो यार बस यही है. There is nothing else in this question. It's actually a very simple question in that aspect. So this is minus 6 power 39 plus 0 plus 6 power 39. And that happens to be 0 mod 13. Right? So that implies 13 also divides our number. Let's say the number is n. So 3 divides n, 13 divides n, that implies uh, 39 divides n. All right. So that is the solution of this question. And you can easily check that 7 and 17 won't work. All right. So that's the thing. For which values of n does 39 divide this? We saw that 39 divided that number because of what? Huh? 3 divides this whole thing, that is not a problem. So 3 definitely, if you call this as some capital M, 3 definitely divides M. When does 13 divide M? So if you take mod 13, it is actually minus 6 power n plus 0 plus 6 power n, right? Mod 13. So when is this equivalent to 0? When is this equivalent to 0? It is equivalent to 0 only when n is odd. So all of the options are correct. Okay, in this question, all of the options are correct. So, so I didn't even need the second slide. Next question. This is related to GCD and all. Okay, given two integers a and b such that GCD of AB is p, where p is a prime number. Which of the following is equals p square? I want to pause. I want you to pause the video and answer the question. I think most of you would have answered it already. Um, If you answered B and D, then you are perfectly correct. All right. So देखो, A will have many prime factors, B will have many prime factors. We are interested in only P. So A will have, A and B commonly will have P. That means A will be P into something, B will be P into something, such that X and Y have GCD equal to 1, right? So we have that much understanding. So what happens in the option A? GCD of A square X, A square B is equal to GCD of P square X square, comma Py. That is definitely equal to P times GCD of Px square, comma Y. Now you see, P and Y uh, may be equal to, like P and Y may have something in common, right? We don't know that. But X and Y definitely don't have anything in common, right? So the answer would be P itself. So GCD of A square B common, if you have to take anything common in both, that has to be equal to P. All right. Now, GCD of A square B square, obviously, that is actually the most easiest. GCD A square comma B square, that is equal to GCD P square X square comma P square Y square. Yeah, that is equal to P square GCD X square comma Y square, and this is equal to P square, because this is equal to 1, obviously. So you see, I think I have to make a little bit of a correction here. Uh, there might be a case, is this always true? Not necessarily. There might be a case if P does not divide X, but P divides Y, right? That might be a possible case. In that case, P is the GCD. So P can be in Y, but P may not be in X. In that case, this will be P squared. This is a possibility. Possible. So that's an interesting thing I just observed. All right. I didn't observe it when I was typing the question. So it is a possibility that A has P square, but it is not true in general. Okay, in general, you cannot say that. But B definitely has this. C, GCD A cube B, that is equal to GCD P cube X cube, comma Py. So definitely I can take P common, and GCD P square X cube, comma Y. Now, definitely you won't, again, there might be a possibility that, this is equal to P, or it can be P square, or it can be P cube also. All these things are possible for this. I can imagine that it is possible. It depends on Y, whether Y has a P, Y has a P square, or what happens. All right. Definitely X and Y both cannot have P, right? X cannot have, if X has P, Y does not have P, it doesn't change. If Y has P and X does not have P, only then these kind of options arrive. This happen only when P divides Y or P square divides Y, only then does this happen. So that is there. But again, GCD A cube B square is definitely equal to P square. You can P square, or I think it can be P cube at most. So if I have to ask which of the following equals P की जगह पे, which of the following can be divided by P? Divided by P. I think that would have been a better question. So in that case, B and D are definitely the answers. Definitely divisible by P square. Divisible by P square. Yeah. All right. So that's an interesting question. Our next question is also related to that. Please pause the video and try the question. I hope you understood this. Let me know in the comments if you understood my explanation regarding the prime factorization of y. Okay, so let's see how many of you got it. If you didn't, maybe I'll make a separate video on this question itself. It's a very, very nice question. Now, yeah, given two integers a and b says that a p square is equal to p, GCD of a p square is equal to p, and b p power 4 is equal to p square. So that means b has the highest power of p as 2. A has highest power of p as p. Got it? So that is a very specific, we are actually given that A has P only. You know, power of P, highest power of P is P only. And B has P square only. This is the highest power. This is also the highest power. Okay. So that is what this question is telling us, where P is a prime. Okay. Which of the following equals P cube? All right. So which of the following equals P cube? Again, AB. If A has P only, B has P square only, then AB has P cube only. So this is definitely equal to P cube. Okay. All right. Now GCD of A plus B. So A is equal to some Px and B is equal to P square Y. Here X and Y don't contain P. Don't contain P at all. All right. So that means A plus B will be equal to Px plus P square Y, which is equal to P times X plus Py. So at most you can take one P common, nothing else. So it is P. Now GCD of A minus B, and again the same thing, right? A minus B will also have P times X minus Py. So this is also equal to P. And GCD of PA minus B. PA minus B, that's a good question. So P square X minus P square Y, that will be P square times X minus Y. So this will be equal to P square. So P cube only one. Got it? I hope everyone is able to follow this. Hmm? Okay. Here the thing is X and Y don't contain P. Both don't contain P. Above the problem was that the GCD is one. That's it for X and Y. One of them or both of them can contain P, and both of them cannot contain P. One of them, only one of them can contain P. So that makes it a bit difficult to process. You know, it's not that obvious. Okay, that's a good thing. Now, if you are actually serious about preparing for ISI and CMI, you know, definitely you might be knowing that every year we launch this batch ISI CMI target ISI CMI batch, which is for mainly students in class 12th and 13. By 13 we mean, you know, the one who are taking drop year. All right, and this batch will be in, you know, taken by Chetan sir, amazing teacher. He's brilliant. I don't need to introduce him to you. I'm guessing that you already know him well enough. So when you know, this is in English. It is starting on 21st July this month, and from 21st 95 plus sessions, actually both have to be highlighted. 95. Okay, so 95 plus live sessions, because ISI CMI the syllabus is very huge. It's a big, because it includes JEE syllabus as well as Olympiad syllabus. It's a big thing. It's a very, very big syllabus thing. So 3 sessions per week, Monday, Wednesday, and Friday from 3 p.m. to 4:30 p.m. 1.5 hour session, 3 sessions per week, and there will be around 20 practice tests. All right. Telegram community will be there so that you can interact with the teachers and your fellow classmates. All right. ये सब कर सकते हो. Assignment, obviously after every session there is a corresponding assignment on that topic, monthly progress report, and for any technical queries, non-academic technical queries, you will have student academic mentor, SAM we call them in short. So that's the thing. And if you use my coupon code ACT Pro, right, you can act now, and you use this coupon code, you will get around 2000 lesser. All right. So I don't know what else you are waiting for. This is this is the batch, and you know that this batch is coming. So yeah, bloody don't act as if you're surprised and all. I don't want to act like that. Come on, just go do it. All right. So yeah, that's all. Now, next question. Now onwards, we will be doing subjective questions. All right. So we all know what subjective questions are. We need to write the solutions. Show that if four positive integers a, b, c, d are such that ab is equal to cd, then the number a square plus b square plus c square plus d square is necessarily composite. Why is that the case? It's a very good question. Pause the video, try to solve it. And there is a reason I have put it in this session. It is not an algebra question. It is a number theory question. It has to do with GCD and all that. So what can we do is, let's say G is equal to the GCD of A comma C. All right. That means my A will be GX and C will be GY. And that would imply GXB is equal to GYT. This get cancelled, and that will imply XB is equal to YD. Okay. Now, since X does not divide Y, that will imply X must divide D, right? That means I can take D to be some X into K, right? So that will imply XB is equal to Y into XK. X get cancelled, so I got B equal to YK. So I have B as this, D as this, A and C as this. Do you think we'll get somewhere? Instead of A square plus B square plus C square plus D square, if it was A plus B plus C plus D, even then, I think you could have gotten this. Do you follow this? It completely uses the fact that A divides CD. Suppose I'm using Greek letters. Alpha divides beta gamma, and alpha comma beta is equal to 1. That will imply alpha divides gamma. As simple as that. This is the only thing which we are using in this whole question. So what did we get? A square plus b square plus c square plus d square is equal to a square is g square x square. b square was y square k square. C square was g square y square. D square was x square k square. Okay. Now, do you see that this is factorizable, right? So just if I take g square common here, this is g square into x square plus y square. Plus, if you see this here, you can take k square common, x square plus y square. So you can write this as x square plus y square into g square plus k square. So this is definitely a composite number. All right. So that is about this thing, this question. I asked you to pause the video. I hope you had paused. Okay. Show that for each integer n greater than or equal to 1, the number this is divisible by 2304. I would want to, again, you can please pause the video and try it for yourself. Yeah. How do you prove this? This number, what is this number? This is a perfect square. This is actually 48 square. Okay. You must notice that this is near 50 square, but this is less than that. So I hope that you will be able to recognize these kind of things during the exam also. With practice, that will happen. If this is 48 square, now we have a picture in our mind that what is this have to do with 49, right? 49, I can write it as 48 plus 1. So 49 power n will be 48 plus 1 whole power n, and that would be 48 power n. So I'm now going to use binomial theorem. So how do we use binomial theorem here? 49, 48 power n plus n into 48 power n minus 1. Wait, I don't think I need from this side. If I write it as 1 plus 48 power n, I think that should be good enough. All right, so I'll have 1 power n plus 48 into, nc1 into 48 into 1 power n minus 1 plus nc2 48 square. So I know 48 square. This is 48 square. So I have something has to do with this. So it is 48 square, 1 power n minus 2, and so on. And rest will be 48 cube, 48 power 4, and all that. So 48 square is common here. So now you see that we need 49 power n minus 1 and n factor. nc1 is n. So now I'll write it very, very clearly. So I'll write it like this. 49 power n is equal to 1 plus 48n plus uh, all this. I can take 48 square common and something. I'll write it as some big n. All this will have 48 square common. All right, because NC2, NC3, all these terms, I hope you know binomial theorem. It is just expansion of this. If you don't know, maybe watch some theory, this thing. I hope you know that. I mean, if you're preparing for ISA, that's the bare minimum. So you have now 49 power n minus 1 minus 48 n is equal to 48 square n. What do we want exactly? We want 2358, 2359, 2352. So 2352 is what? It's actually 2304 minus 48. So if you add or maybe subtract, you're adding. So subtract 2304n. So this is simply 48 square into n minus n. So we are done. Like this is this expression is divisible by 48 square, which is 2304. That's it. Simply uses binomial theorem, nothing else. All right. And I want you to show this as homework. Use this as homework. This is also very, very similar. All right. Just look at it very carefully. It also uses binomial theorem, but a little bit of trick is there. So be a little bit of careful. Okay. So yeah, that's it. That's it for today's session. There was the first session. I wish to take some longer sessions, so I'll take a longer session later as we progress. Good topics comes up, I'll take good sessions. All right. So till then, tata, bye bye, take care.